Today we're going to talk about functions. What is a function? A function, other than being fun, is a set of ordered pairs where each x value is paired with only one y value. How can you tell if this is a function? What you want to do is you want to check to see if each x is paired with only one y. So if we take a look at our x values, we have a 3, and then we have a -1, a 4, an 8, and another -1. If you see that you have an x value that is repeated, then it is not a function. So since these are repeated x values, this is not a function. Go ahead and take a minute to look at this one and decide if it's a function. Pause the video, make your decision, and then play it in order to check your answer. Okay, taking a look at this data, if we look at our x values, I notice that none of them are repeating, and so yes, this is a function. Sometimes instead of giving you just a list of ordered pairs, we give you what's called a mapping. In order to read a mapping, what you want to do is you just want to take a look at your x value and then see where it's paired up with. So one ordered pair would be -4, 10. Then you would see that -2 is pointing towards the 23, so -2, 23. Now, one way I like to look at a mapping to decide if it's a function is I think of it like each x can only go to one place. So if you have an x value that's traveling to two different places at one time, that's not possible. Again, if you notice the -4 is only going to the 10, the -2 is only going to 23, 6 is only going to 3, and 8 is only going to 24, that means yes, this is a function. Now if we look at this mapping, you'll notice there's a difference because the -1 on the x side is going to two different places. It's going to -7 and it's also going to 8. That means this is not a function. This is another way that the data can be displayed, and this would just be a table. It's kind of like a list of ordered pairs, and so what you want to do again is just check and make sure that there are no repeating values of x's. This one there is not, and so that means that yes, it is a function. And one more type of data display that you'll be looking at is a graph. In order to tell if these are functions, what you want to do is you want to use what's called the vertical line test. If you take your pencil and you go over this first graph going from left to right, we just want to make sure that the line and the vertical line only meet at one spot throughout the entire graph. So if you notice, this one only intersects in one point throughout the entire graph, so this is a function. The second graph, if we do the same thing, 1 point, 1 point, notice that it's just touching that orange line 1 point at a time, going all the way across. So once again, this is a function. And the last one, as soon as I hit this spot right over here, you'll probably notice that it touches in two different spots at one time, and so this is not a function. Now let's talk about what's called function notation. You probably recognize this right here. We have seen equations written in this form before, and usually there's a number here in this spot, and that number represents the unit rate. Well, now, in order to write something in function notation, what we're going to do is we're just going to take this y, and instead of writing y equals 5x, we take out the y and put in f of x, just meaning that it's a function. So notice instead of y here, it says f of x equals, and then we can put our 5 in. So y equals 5x means the same thing as f of x equals 5x. Now, why would you need to use this? You're going to use this to calculate function values. So if I tell you that the function is 2x minus 4, then I can ask you to evaluate the function if x is equal to negative 7. So how you would do that is we would say we want to find f of negative 7. And so we're going to plug in negative 7 where the x is in our function. So we end up with 2 times negative 7 minus 4. So this would be negative 14 minus 4, which is negative 18. So the value of f of negative 7 is negative 18. Okay, now let's take another function. Let's say that f of x is equal to 9x plus 3. What is f of 4? So, again, what we're going to do is we're going to take the 4 and plug it in where x is located in the function. So we get 9 times 4 plus 3, and that equals 39. Okay, now it's your turn. Go ahead and pause the video and try finding the following function values. Then play the video to check your answers. Okay, let's check your first answer. For number 1, we wanted to find f of negative 7. So we should have taken negative 8 times negative 7 plus 6. That would be 56 plus 6, which is 62. For number 2, f of negative 4, we're going to take 5 times negative 4 and then add 1. So that's negative 20 plus 1, which is negative 19. And then lastly, we're plugging in 9 where the x is. So we have g of 9. Which would be negative 90 plus 8, which is negative 82. Okay, I'm going to go ahead and have you try a few more, but before you do that, if you notice there's something that looks a little bit different here, number 2, you're supposed to find f of 2, and then at the end, after you get your answer, that's when you add 1. Same thing with number 3, you're going to find f of 6, and then at the end, subtract 2. Be careful with number 4, that's a tricky one. Your answer should have an m in it because you're going to be plugging in 5m where the x is. Go ahead and try it. Okay, let's go through each of these problems now. So first we're going to do f of negative 4. So we have negative 4 to the second power and then subtract 2. So that would be 16 minus 2, which is 14. For number 2, my directions were to find f of 2 first. So let's go ahead and do that. We have 2 to the second power minus 2, which equals 2. Now we have to add 1 to our answer, and so we get 3. The next problem, we're going to first find f of 6. So we have 6 squared minus 2, which is 36 minus 2, which is 34. Then subtract 2. And we get 32. Okay, now the last one. We need to plug in 5m where the x is in our function. And now what we're going to do is we're going to simplify this. So 5m to the second power really means 5m times 5m. 5m times 5m is 25 m squared, and then I have the minus 2. I cannot simplify this any farther though because the 2 doesn't also have an m squared. So my answer is just a simplified expression, 25m squared minus 2.